Auzu billahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear students of 12th class, subject Botany. Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, today on 16th of July 2021, our topic is Mendel's law of independent assortment. This is the third law of Mendel about the principle of inheritance. So, our today's topic is law of independent assortment. Dear students, first of all, we will define this law of independent assortment. The law states that if the inheritance of two or more genes at a time is considered, their distribution in gametes and in progeny of subsequent generations is independent of each other. I will say again that this law of independent assortment states that if the inheritance of two or more genes at a time is considered, their distribution in gametes and in progeny of subsequent generations is independent of each other. This law of Mendel, that is the law of independent assortment, can be explained by dihybrid cross. Dear students, we have studied the monohybrid cross and the Mendel's dihybrid cross, and with the help of dihybrid cross, this third law of independent assortment, can be explained. So what is done? A dihybrid cross involves inheritance of two different characters at the same time. This is the dihybrid cross, which can be defined as the involvement of which can be defined as a dihybrid cross involves inheritance of two different characters at the same time. Mendel crossed to how the Mendel explained his third law of independent independent assortment. Mendel crossed true breeding tall plants bearing red flowers with true breeding dwarf plants bearing white flowers. So two types of flowers are the two types of plants, that is the tall plants and the dwarf plants. As the tall plants bear the red flowers and the dwarf plants bear the white flowers, these two types of plants are crossed with each other. Tall being dominant over dwarf and red being dominant over white. That is, the tall size of the plant is dominant over the dwarf size of the plant, while as the red color is dominant over the white color. So what will be the effect in progeny? In F1 progeny or F1 generation, only tall plants bearing red flowers were obtained. So when the cross is made between tall plants bearing red flowers and the dwarf plants bearing white flowers, in F1 generation, only tall plants bearing red flowers were obtained. While as in F2 generation, Mendel obtained four types of plants. In F2 generation or in F2 progeny, Mendel obtained four types of plants. Those four types of plants were tall red, dwarf white. These were the two types of plants, that is tall red and dwarf white. These are both parental combinations. While as the other two plants like tall white and dwarf red, these two plants were both new combinations. So two types of combinations, parental combination containing two types of plants, and the new combination is containing the two types of plants. That is, in total, four types of plants were obtained. The ratio obtained was, so what was the ratio of these four plants? Tall red wire 9 plants, tall white wire 3 plants, dwarf red wire 3 plants, and dwarf white wire was 1 plant. So this was the ratio of dihybrid cross. 9 is to 3 is to 3 is to 1. On the basis of this dihybrid cross, Mendel tried to explain this third law, law of independent assortment. So, dear students, we will conclude here our today's topic, but the topic is continued, and the second part or the remaining portion of this question, independent assortment, can be discussed in our next lecture tomorrow. Inshallah, till tomorrow, stay home, stay safe. Thank you very much.